So at this point, we now have our router initially configured, got the IP addresses set up, we've got Telnet, SSH, we've even gotten into the SDM, set that up, and configured the DHCP services. So all of our computers on our network are starting to get IP addresses and they can actually communicate on the local network. Now it's time to do some real routing. That's what this video is about. Implementing static routing, the first level of routing that we'll talk about. We're going to take a look at what the purpose of routing is in general and just see essentially what routers do. Then we'll move into how static routing can help. Up till now, it's kind of hard to believe, but up till now in this series, we have seen how routers sit on the network and have IP addresses, but they're not routing yet. Meaning they've got IP addresses and they're happy, but they're not actually routing packets. So we'll see how static routing can help that. Finally, I'm going to take you through some configuration and design scenarios for static routing that I think will be very beneficial to help put all these concepts together. Let's start things off by just talking about the purpose of routing. Up till now, we've talked about our routers as these circular devices that sit on network diagrams and have IP addresses. And I'm sure you may remember from early on in the series, I said the purpose of routers is to stop broadcasts, but allow you to move packets from one network to another. The problem right now is that our routers, sure enough, on our network have IP addresses. We assign these IP addresses in some of the previous videos to our routers, but they're not actually routing yet. Meaning they know what networks they're connected to, but they don't actually know much beyond that. Let me give you an example. As of right now, in the previous video, we set up a DHCP server, and this client ended up with the IP address 192.168.1.20 from the DHCP server. Now let's just take a look at what this client can really do. I'm going to bring up the window, and let me kind of scoot things around a little bit. There we go. Just so we can see the start menu and stuff like that. I'm going to open a command prompt. I'll just type in CMD in the window here and drag it down. We can see our command prompt. I'll just do an IP config to make sure everything looks as it did last time. Yep, we still got our IP address. We even have a default gateway. Now, if I wanted to, as a client, I could communicate with anything on my LAN, meaning anything that is on the same network as me over... Let me get this down in the window here. Over here. So I could, if there was another device over here that had 192.168.1.50 as its IP address, I could communicate with that because it doesn't require a router to do that. I would just ARP for its MAC address and go straight over there. Now, I can even communicate with my router directly. For example, come back over to my client. I could type in ping 192.168.1.1 and hit enter, and it says, yep, sure enough, I'm getting replies. I can talk to them. If I wanted to, I could telnet to my router, telnet 19. Oh, I love Vista in that they don't include a telnet program by default. So I could open TerraTerm on Vista and drag it down into the screen here. Oh, good grief. Oh, we're falling apart at the seams. I'll hit new connection and say 192.168.1.1 and telnet using TerraTerm over to my router. And you can see I'm communicating with my router just fine. I'm able to speak, if I could remember my password. And I'm sitting on my router right now and do all that because, right, looking at the diagram, the router is sitting on the same network as me. So all I got to do is ARP for the router's MAC address, and the router says, oh, here's my MAC address, and I can get that. Now, I can also, from my computer, talk to the router's public IP address. Well, I mean, let's try that. 68.110.171.98. Let me jump back over here. Let's get rid of this TerraTerm window. Ping 68.110. What did I say? 171.98. Let me just double check. 171.98. Yep, that's it. I hit enter, and you can see, sure enough, I can ping that IP address. I could probably even telnet to it if I could use Vista's telnet client, which I can't because it's not installed by default. Curse you, Microsoft! Minimize that. All right, now I'm going to, okay, so we've realized that I'm able to communicate with things here on my local network, and I can even communicate through the router, if I will, to its public IP address. But now take a look at this. The routers linked up to the internet service provider, And I'm sure from the router, I could actually, let me give a little easier window here. From the router, I'm able to ping the internet service provider at 68.110.171.97. Let me do that. Ping 68.110.171.97. And sure enough, yep, I've got 5 exclamation points, which means 5 success replies has come back. I'm communicating with the service provider, but let's see, from my router, can I really, get somewhere on the internet? I'll try and get to that DNS server we've been using up till now. Ping 4.2.2.2. I hit enter. Nothing. I'm dying. Why is my pings not going through? Well, I come back to my slide title. The purpose of routing is to turn our routers to the ability to do some routing. By default, a router, if I type in the command, which we'll see a lot in these next few nuggets, show IP route, I hit enter, I'm able to see what networks the router knows about. Now up here I see all the codes. These are all the codes showing the keys down here. As of right now, the router knows about this network, 68.110.171.96 network. That's the /27 subnet mask, because it's connected. You see the C? Connected. It's plugged into that network on its fast Ethernet interface. So it knows about that network and it can reach that network. That's why I'm able to ping my service provider, is because I'm plugged into the same network as they are. I can communicate here because we're on the same network. Likewise, I'm sitting on my Ethernet interface, or my VLAN 1 interface. I'm connected to 192.168.1.0/24, so I can reach things on that network. But when I pinged the IP address 4.2.2.2, the router went and looked at its routing table and said, I don't know how to get there. I'm looking at, I don't know how to get to anything that starts with 4. That's what the routing table is. It's a list of networks that the router knows how to reach. And as of right now, the router is only able to reach things that it's directly connected to. So that is where we come in as administrators. We need to help that. We need to fix that in the sense that the router needs to know how to get to things. Let's look at a little simple scenario down here. And we're going to set up both in this video. I've got a client, plugged into 192.168.1.0 network. This could very well be our .20 client that we're using right here. And we've got our router right here. That's 192.168.1.1. And we've got this WAN link communicating. We'll say this is 192.168.2.1 right here. And maybe this is 192.168.2.2. That's the WAN link network between the two. And then this router has the 192.168.3 network over here. And maybe, I don't know, there's the client over here with 3.20, and this is 3.1 on this side. Now, with this setup, if I just plugged all this stuff together, connected the cables, got our WAN link running and our LAN port, everything's plugged in. As of right now, if I was sitting on this router, we'll call it router 1, I would only be able to reach things that are on the 192.168.2 network, meaning I could maybe ping this router right here, and I could only reach things that are on the 192.168.1 network because I'm directly connected. I'm plugged into them. Router 1 could not reach things over here on the 192.168.3 network because it does not know that it exists. Now you might look at the diagram and say, well, yeah, Jeremy, it's plugged into the router that's plugged into that network. Sure it is. But router 1 is not smart enough to understand that router 2 over here has the ability to get it to that network. Routers only know what they're directly plugged into. Likewise, router 2 can reach 192.168.3 and .2, but it does not know that this 192.168.1 network over here exists. The result? This computer cannot communicate with this computer because the routers are not yet routing. We've defined the problem. Now let's talk about the solution, how static routing can help. Static routing is where you, as an administrator, get onto the routers and start telling them where to go. What I did was I just pulled the simple scenario from the previous slide that we can look at to start things off, and then we'll get more complex and add more pieces. As of right now, at the bottom of that last slide, we had 2 routers that could not reach each other. Or, well, they could reach each other, but we couldn't reach the PCs behind them. Now, just so we've got a complete diagram here, these PCs behind each one of the routers are the .20 address of the 192.168.1 and 192.168.3 ranges. So we, using static routing, can log into these routers and tell them where to go. Thus the name static routing. Manual. You as an administrator get to go in there and type in everything. It works great in a large network if you're paid by the hour, but very painful because you have to go to every single router and direct them. Let me bring up the configuration window and walk you through the syntax to make this happen. I'm sitting on router 1 right now, and I'm just going to get us familiar with where things are at. I'm going to do a show IP interface brief, my all-time favorite command. And you can see that I have fast Ethernet 0/0. That's this interface right here, connected to the LAN with the IP address 192.168.1.2. Oh, whoops, network diagram inaccuracy. This should be 192.168.1.2 because this is actually part of the bigger diagram. This line goes up here and connects to our other router that gets us off to the internet, the one we've been configuring so far. This is a new router, 192.168.1.2. So I'm sitting on this router. I've now verified the IP address, and I'm very glad I did, to see that this is the .2 of 192.168.1. And if you look at the serial interface, that's our WAN link. We'll talk all about the WANs in a few videos. But that is 192.168.2.1. See the .1 interface right there back on the diagram of 192.168.2. You can see that right here. Now, I'm going to telnet over. I'll type in telnet 192.168.2.2, 2.2, which is router 2 over on the other side. Hit enter, get our lovely logon banner, and I'm going to log in, get into privilege mode, and do some verification there as well. We've got show IP interface brief. I've got 192.168.3.1, which is connected to the LAN interface. You take a look to the right of router 2, the 192.168.3.1 interface that's verified. We've got 192.168.2.2, which is the WAN link that's connecting back over to the other side. And then we've got 3.20, that's a loopback interface. I'll talk more about that later, but that's my way of simulating a PC actually plugged into the port over here because, well, I ran out of computers and I don't have one to attach there, but that will simulate as if there was a PC there and will act as a good way to do some tests. So let's get back over to router 1. I did my Control-Shift-6X. That suspends the telnet session. I'm back over on router 1. I'm going to do the clear buffer, and I'm going to type in a show IP route command from router 1 and verify that router 1 can only connect to 192.168.1 and 2 because that's the only networks it knows about. So let's do some tests. I'm going to do ping 192.168.2.2, make sure I can ping router 2 so I can reach over there to router 2. But when I do ping 192.168.3. Well, let's just be basic. Let's do 3.1. That's the LAN interface of router 2. I hit enter and you can see the pings are dying. Because router 1, while it is connected to router 2, it does not know about the 3 network behind it because it's not directly connected. So let's fix that problem. I'm going to get into global config mode and type in IP route. This is the syntax for a static route. If you got a pen and paper, you may want to jot this down because this is some big syntax. IP route, and I hit the question mark, and it says, what is the destination network you're trying to reach? Well, I'll type in 192.168.3.0. It's asking for the network, not the IP address. I'm saying I want to reach everything that starts with 192.168.3. That whole network. Hit the question mark and it says, what is the mask for that network? And I say, well, the subnet mask is 255.255.255.0. It's a Class C network. And I hit the question mark and it's giving me a lot of options right here. It's saying you can either type in what interface you want to go out to get to that network, or the more common one is what is the next hop IP address to get you there. That's what we're going to use here. I'm going to say to get to the 192.168.3 network, I need to use 192.168.2.2. That is router 2's interface. Essentially, this syntax says, I would like to use something I know about, or am able to reach 192.168.2.2 to reach something that I did not previously know about, 192.168.3.0. Does that make sense? So router 1 is going to go to 192.168.2.2, router 2, in order to reach 192.168.3.0, the network behind it. Now, if we were grabbing a little packet trace here, router 1 would go choo and send a packet over to 2.2 to reach, we'll say 3.1. Now, does router know how to get to 192.168.3.1? You bet it does. It's plugged right into it. Of course it knows how to get there. So router 2 will be able to answer that request. So let's bring our connection back up here. I'll hit enter, hit Control Z, get back to privileged mode. I'm going to first off, type in show IP route on router 1. And you can see that it now has a static route, thus the S, saying to reach 192.168.3.0, I'm going to go to 192.168.2.2. That's router 2 on the other side. So now's the big moment. Let's ping them. Ping 192.168.3.1. Enter. Sure enough, we're now successful, whereas before we failed because it now knows to get to that network, it needs to go to that next hop IP address. But we're not done. Router 2, unfortunately, does not know how to get back. Meaning, let's do a show IP route on router 2. Sure, router 2 knows how to reach the 192.168.2 network that's directly connected, and the 192.168.3 network over here, 2 and 3, but it's not able to reach the 192.168.1 network over here on the other side. So let's do a test first of all. I'll do ping 192.168.1.2. And I can tell you this is going to fail because just looking at its routing table, you notice there's nothing in there about 192.168.1, anything. So we need to do the same thing on the other side. Get into router 2. I'll type in IP route 192.168.1.0. That's the network I want to reach with the subnet mask 255.255.255.0 question mark. And I want to use 192.168.2.1 to get there. That is going to be router 2 going to router 1. It's saying, I know how to reach 192.168.2.1 because I'm plugged right into it, but I need to send my packet there because that's how I'm going to be able to reach the 1 network. You seeing how we build this kind of like link by link? Hit enter, and now I can come back, and I'll just even hit the up arrow a couple times, just do a ping 192.168.1.2, and now we are successful. It is able to reach router 1 successfully because it knows how to get there. We've added that entry to the routing table right there. And just so you know, I've got an Outlook reminder popping up in the background to call about my stampstone cracks. Cursed stampstone cracks in the backyard. Sorry about that. So that is the routing table that's reaching between those two devices. We've now implemented end-to-end routing using static routes. Now that was implementing it using 2 routers with 2 networks. That's why static routing is so painful, is because now if you've got more routers or more networks, you have to go network by network by network by network, adding them in one by one. Now that solved one of our scenarios that we saw the issue with, which was reaching between 2 offices, meaning crossing a WAN link to 2 networks behind the office. But there was another scenario on that initial opening slide to the video that showed our router we've been configuring all along, the CBT router. And we said, you know, there's some issues here because, yes, CBT router can ping its ISP. Oh, let me type in ping 68.110.171.97 here, and that's working okay. You know, we're able to reach over to the other side, but it's not able to ping the internet. So, you know, if I just wanted to reach like some DNS server out there, you know, that's failing. If I were to do another test, hang on. Let me try this. I'm gonna figure out Google's IP address. Let's do a ping google.com. And there's Google's IP address. Let's see if our router can ping Google. You know, my computer just did. And by the way, it's not this computer in this picture. That's our lab computer we're working with. I'm going to try and do a ping and just paste, lost it. All Right there. Let's get Google's IP address one more time. And I'll do a ping and paste in Google's IP address. Yeah, we're coming up short here on our router because it doesn't know about the internet. Meaning our router does not have a route to do anything. Let's do a show IP route. And you can see the only things it knows how to reach is its link to this service provider, that's this network, and its LAN interface, 192.168.1.0. That's this network right here. So of course, when I'm trying to ping Google's IP address, the router's going 72.14. I'm looking at my routing table. I don't have any idea how to get there. Or when I ping the DNS server up here, it's saying 4.2. Looking at my routing table, I have no idea how to get there. Now here's the question. How on earth do you come up with a route for the whole internet? There's your paid by the hour, right? Typing in every single network on the internet one by one is statically. Well, thankfully, Cisco has a much simpler way, and this is one of the big areas static routes are used all the time. It's known as a default route. When you go into a router into global configuration mode, you can configure a default route that tells the router, you know what, router, anything that you don't know how to reach, go ahead and send it over here. It's kind of like, you know how computers have default gateways, and pretty much they say, hey, if there's something not on my network, I'm going to send it to the default gateway. Well, in the same way, routers have default routes that say, well, if there's something I don't know about, if it's not in my routing table, I'll use the default route to get it. Here's how you do it. I'm going to type in IP route, but when it comes to the network I'm trying to reach, the network will be all zeros. And that is how Cisco routers understand anything. It's saying, I want to route for any IP address, and I'll hit the question mark, and it says, well, what subnet mask? And I'll say, any subnet mask will go to, and now it's going to know, well, where do I send this to? I'll say send it to the ISP, 68.110.171.97, because the ISP or their router definitely knows how to get to things on the internet. That's what ISPs do. So what this syntax really says is send any IP address with any subnet mask to that if you don't have a more specific route in your routing table. Does that make sense? That is a default route. So once I hit enter, this router, let's go back here, I'll type in show IP route. Our CBT router says, I have a static route. Notice it put a little star by it. If you look right here, it says, oh, I recognize that as my default. It's saying send anything with any subnet mask to our ISP. You notice up here, the router also filled in gateway of last resort is this. If we looked at our routing table beforehand, before we typed that command, it said it wasn't set. I don't know. I don't know what my last resort is. So, you ready to test it? I'm going to see, it's so exciting to me when I get to do this. I'm going to ping 4.2.2.2. Think it'll work? God, I just like building up the anticipation. Look at that. Sweet. We now have a working route to the DNS server on the internet. Hey, let's try Google. I'll hit the up arrow. There it is. There's Google's IP address. And sure enough, Google is responding as well. Not quite as fast as the other one. You can see it took a little more time to get there. But Google is working as well. I can actually go on here and ping any internet address. Oh, sorry, I just had a brilliant idea. Let me show you a command. I haven't showed you this yet. But remember how we can configure our PCs for DNS servers to where, you know, when they want to look up a name like google.com, they can send it to a DNS server and find out what it is. Well, we can configure our routers to do that as well. The command is actually IP name server. And I'll say I want to use the DNS server 4.2.2.2. And that allows our routers to resolve names so I can actually figure out what IP addresses map to what domain names. Now I'm going to try and type in ping www.google.com. Look at that. Isn't that awesome? It says I'm going to figure out who google.com is using the domain name server 4.2.2.2. That's the public internet DNS server I mentioned about. I can ping cbtnuggets.com. Oh, come on. CBT Nuggets. See, it resolved the name for CBT Nuggets, but CBT Nuggets is very secure, and they have a firewall that blocks people from pinging them. And that, sure, fair enough. I totally understand CBT Nuggets network. You don't want to try and hack in there. Let's see now. Now I can't even think of a name. What's a good name? Let's ping Yahoo.com. You know what? I should make a whole video of just pinging stuff. It's so much fun. You can ping stuff all day, all night. And Friday night, you're sitting there, you're like, what do I do? Ping some domain names. And now we can see our router is routing to the internet. I got to get off this kick. Here's the catch, though. We've got our host right here, which is using this router as its default gateway. What do you think? Will it be able to surf the internet as of right now? I mean, the router says, I will send anything I don't know about to the internet. And this computer right here is saying, well, I'll send everything I don't know about to you. Do you think it'll happen? Well, sure, let's try it. I'm going to go to my PC and open a command prompt. And we were able to ping the 4.2.2.2 from the router, right? We proved that. Let's try it from the PC. I'll do ping 4.2.2.2. Enter. And by the way, I'm accessing this PC remotely. That's why we've got these little jagged things here. I'm using something called VNC. So it's dying. It's not working. Why not? Well, let's do another command. I'm going to type in traceroute, which will show where the computer's sending data to 4.2.2.2. And that will allow the computer to hang there for an extremely long time. Because God bless Windows Vista, it's trying to look up the name for 4.2.2.2, and that's why it takes so long. So it's saying, I'm tracing the route to 4.2.2.2 over a maximum of 30 hops. Like I'll go through 30 routers to get there. And it's coming up and saying, my first hop, it takes 1 millisecond to get there, 1 millisecond. It actually tests every single hop along the way to see how long it gets there, is 192.168.1.1. Well, if you look back at our network diagram, that's right. Good job, computer. You know where you're going, 192.168.1.1. But when it gets to this router, it dies. Notice there's no times, it's just dying because it's trying to say, well, where do I go from there? The reason that it's failing is because right now the router is trying to send that IP address out, but you know what the problem is? Recognize anything about that address that just is not very internet happy? That is a private address. Meaning, as this computer is passing through that router, the router is trying its best. It's actually sending that out to the ISP. But as soon as the ISP gets a message from 192.168.anything, it says, you are a private address, and I am going to drop you. Sneak peek to a later video. That will require a feature known as NAT. Network address translation. You may have heard of that before. We'll be configuring that a little bit later on. Let's just glance back at our computer. You can see it just dies right there. It's not going anywhere. So we know that we are not able to route out to the internet yet, not because routing isn't working, but because that's just private addresses. Okay, this is where things get awesome. We are going to combine the two pieces into one, meaning I've been building piece by piece this network scenario up to this point. We set up, in the first demonstration, I set up the static routes to go from router 1 to router 2 that allowed router 1 to ping, 192.168.3.1 over here and this host .20 on the other side. We have router 2 that is now capable to ping 192.168.1.0 or anything on this network. .20 is our host sitting over here. Now let's put the two pieces into one. This has our internet route. Let's bring up our connection to our CBT router sitting up here and bring it into the fray, because as of right now, sure, this guy's got an internet route and it can route this off to the internet. It's just not doing it right because it's not using NAT yet. So let's set up CBT router to make sure that it's able to reach this network over here. and kind of put the big summation on our static routes. So let's go right here. I've got the CBT router. I'm going to do a show IP route command on there. It knows how to reach its internet link because it's connected to it, 192.168.1 because it's connected to it, and the entire internet because I have a default route we just put in there. But it does not know how to reach, well, anything it's not directly connected to. 192.168.2.0 doesn't know about that one, nor 3.0 because it's not plugged into them. So let's just do a quick test. I'll do a ping 192.168.2.1. Nope, not getting there. I don't have to wait. I can do Control-Shift-6, which kills the pings and doesn't wait for it to finish. So if I'm going to create a static route, I want you to do this. See if you're ready. Pause the video and grab a piece of paper and write it down. What syntax would I put in to my CBT router in order to allow it to ping the 192.168.2 network, meaning reach the .1 and .2 route around there? Go ahead and pause the video right now and jot that down. Okay. You've unpaused the video, or you just don't feel like pausing it. So I'm going to bring that link back up, and I'm going to go and do CBT router. The command will be IP route, network I want to reach, 192.168.2.0. Subnet mask of that network, 255.255.255.0. And the next hop to get there, well, the CBT router needs to go through, I put this first arrow as a hint, 192.168.1.2. That's the IP address of router 1, 192.168.1.2, in order to reach 192.168.2.0, or this network over here. So I'm going to show you something really cool right now. Let's try it. Oh, it's more cool than you may be thinking. I'm going to type in show IP route, make sure the route's in there. Yep, there it is. There's my static route, 192.168.2.0. I'm going to ping 192.168.2.1. That's the interface of router 1, right? Sweet success is at hand. We've got 5 successful pings happening. But that's not the really cool part. Here's what I want to show you. I'm going to ping 192.168.2.2, the other side of the WAN link. Oh, wait a sec. Never mind. It's not going to be as cool as I thought. 192.168.2.2. And it works. It is successful. Yes, that is cool. That is cool. But I was thinking in pieces. I was hoping it would fail. I know that sounds bad, but I just remembered we already put the route in here to reach 192.168.1.0. We did that early on when we first started doing this. So router 2 knows how to get here. The thing I was going to say was going to be really cool was if this route didn't exist, meaning router 2 did not know how to reach 192.168.1 network, the ping would fail. Not because the CBT router couldn't get there. CBT router, because we added in the IP route command, knows how to get to router 2. It's that router 2 wouldn't know how to get back to the source IP address that CBT router was coming from, 192.168.1.1, without that route sitting in there. But I forgot that we added in that 1.0 route, so it did work successfully. So CBT router is now able to reach this WAN link, 192.168.2.0. What do you think? Can it reach this PC over here? Let's try it. 192.168.3.20. Utter failure. The reason why is, again, we don't have a route in our table for 3.0. We've got 2.0. We can ping the WAN link in that whole network, but we don't have one for 3.0. Let's fix that, and then we'll wrap up static routing. I'm going to type in IP route 192.168.3.0, 255.255.255.0. Oops. It says incomplete because now it's going to say, what is the next hop address that you're going to use to get there? What do you think we're going to use? My word, how do we even see things going on? Clear that off. What? Oh, good grief. I'm losing links left and right. Bah! There. Goodbye. Goodbye. Oh, link failure. So we lost our link. No, but what was I talking about? Oh, what is the next hop IP address? I'm sorry. I get so excited I just freak out and forget everything. I see 192.168.3.0. That's my destination network from the CBT router. But what is the next hop IP address to get there? It is not 192.168.2.2. That is not the next hop IP address. The next hop IP address is again 192.168.1.2. That router is the one that has the route to get you to that router, which is the one that has the route to get you to that network. You see how this routing is a hop by hop by hop thing? So, one more, whoa, my goodness. One more time, I'm going to put in 192.168.1.2. 1.2, which is router 1's IP address right there. That'll be the next hop route to get us there. Now let's try it again. I'll do ping 192.168.3.20, and we are successful. We are fully routing now through the entire network using solely static routes. Now, that is an awesome way to set up routing. Static routes are very beneficial, but can you see just how much work they can start becoming? I mean, this was in our little network of 3 routers, essentially representing one corporate office and one branch office right here. Imagine a network like Intel or Motorola or Singular or, name your big company right here that have hundreds of branch offices and hundreds of locations, thousands of locations, millions of networks at hand. Am I being extreme there? Probably. Maybe hundreds of thousands of networks at hand. Are you going to statically set up routes all around that? How about no? That's where the next video is going to come into play on dynamic routing. But for now, we've seen some pretty cool static routing scenarios. Let's wrap this one up. We saw implementing static routing by first understanding the purpose of routing in general. It's to move packets between networks reliably, and the router must know about those networks in order for it to do routing. We then saw how static routing can help. It's where we, as an administrator, can come in and say, to get to this network, you need to go there. And then we manually program every single route that exists in our network. We then saw multiple, I think 3 or 4 total design scenarios and the configuration for each to implement static routing. I hope this has been informative for you, and I'd like to thank you for viewing.